Okay, this is our last section. So the chapter ends and the semester ends. Last topic is scaling. And you know this from like maps. When you scale maps, you scale different things. Its converting units is scales. We've already used the word scale to refer to scaling a ratio in a proportion. And you probably also know this from equivalent fractions. We use the number 1, some scale, to change one fraction into another equivalent fraction. In the previous example, in 5.4, we could scale the conversion 100 units per 250 milliliters by 4.8. So we're taking a ratio, multiplying it by 1, 4.8 over 4.8, and we get that. So 100 over 250 is equivalent to 480 over 1200 units milliliters. The new ratio, 480 units per 1,200 milliliters, is equivalent to the original concentration. Similarly, we can scale images on our computer by grabbing the corner and dragging. And we've done this a lot. So we can take a little picture like this and blow it up to like this. Now this is scaled, right? The new image is in proportion because the length and width have been scaled by the same factor, like the 4.8 above. If we just scale the length, the rabbit looks stretched, and this would not be proportional. A scale is an agreed upon factor which changes the size or magnitude of quantities but keeps the relationships in proportion. So there's the definition. A scale is a ratio that represents a change in magnitude used to keep relationships in proportion. In proportion means the same thing as equivalent fractions. A map or model scale is a ratio between the actual distance and the distance in the map or model. Following map of the United States from a cover of the New Yorker is not to scale. That's not a scaled map. The map gives a relevant viewpoint of the country from a New Yorker's perspective. They know their immediate surroundings and vaguely know Chicago and Las Vegas are out there somewhere, Canada and Mexico and the Pacific coast beyond. So this is certainly not to scale, but it's a New Yorker's perspective. Maps, therefore, do not always have to be to scale. It depends on the intent of the map maker. A beautiful map shows the regions of the U.S. that voted for Hillary Clinton in 2016. And it's a little hard to see, but every major city is like an island, showing how Clinton carried the urban vote, the city votes, city, 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 but lost badly in rural America. This map is actually to scale, meaning that the distance between the cities are in proportion. The distance from Boston to Philadelphia is 306 miles. Boston to Philadelphia, 306 miles, a bit shorter than the distance from San Diego to Las Vegas. San Diego to Las Vegas, which is 326 miles. So here's our first example, 5.21. So we have like a road map or some kind of a map, and it's drawn using a scale of 100 miles equals 1 inch. Now clearly 100 miles does not equal an inch. So this is not we're not converting, we're scaling. It's different. How far apart are the following cities on a map? Boston to Philadelphia. So from above, we know that Boston to Philadelphia is 306 miles apart. So we're going to use that. And we just set up a proportion, 100 miles to 1 inch, because that's the scale, and it's going to be equal to 306 miles to x inches. Cross multiply and divide. All right, similarly, we can solve for a map distance between Boston and Chicago. And actually, this is not a map distance, this is the actual distance. We're going to solve for the actual distance given the map distance. So think about how I'm going to set that up. I'm going to put it in here. Okay, so hopefully you figured this out here. Here's our scale. Here's our unknown miles and our known inches on the map. Cross multiply, and we don't even have to divide. And so we get 852 miles. So that's the distance in actual miles between Boston and Chicago. Now, here's a caution. Note, the scale is 100 miles to 1 inch. It's not a conversion. 100 miles is much longer than 1 inch. A conversion starts with an equivalency. For example, 1 foot equals 12 inches. All right, so it's completely different, but it's scaling. Model scales are typically given without units. A 1 to 72 scale means 1 inch, mile, or whatever in the model for the model car, for 72 inches, miles, whatever for the actual car. Obviously, cars aren't going to be miles. But 1 to 72 means you can use any unit, but they have to be the same because they would cancel when you divide, right? 1 millimeter for the model car is 72 millimeters for the actual car. That's a 1 to 72 millimeters, inches. A scale of 1/4 inch per foot is not a unitless scale. A 1/4 inch divided by a foot, that's not unitless because inches and feet are not the same. If there are no units attached to the scale like this, like the 1 to 72, then it is unitless, okay? Tiny homes have become popular due to the cost and environmental concerns. I love tiny homes. Indeed, over the last 42 years, the average new U.S. home has increased in size by over 1,000 square foot. From this in 1973 to this in 2016. Don't ask me why. Given the floor plan below for this tiny home, find the square footage. So we're going to find how many square feet are in this tiny home. But we first got to find the actual length and width. And here is a model, a floor model of the tiny home. Notice the scale is 1/8 of an inch equals 1 foot. That's the scale. The length is 3 1/4 inches and the width is 2 3/8. Is this unitless? No, it's not unitless. Inches per foot. So I'm going to set up the two proportions. One to find the length and one to find the width. I'm going to put them here. Think about how I'm going to do that, knowing that there's my scale. Okay, so here's how, and I'll blow that up a little bit. Here is how I did the length. We know that 1/4 of an inch is, the scaling is 1/8 of an inch per foot. And I know I have 3 1/4 inches here, and I want to know how many feet. Cross multiply, I get 1/8 of an inch times x equals 3 1/4. Now, to solve this, you can either multiply by 8 or divide by 1/8. Remember, that's the same thing. So let's say I multiplied by 8. Multiplying this side by 8, I get x. Multiplying by this side by 8. This is how I would put it in my calculator. If you know that's 0.25, you can put in 3.25. If you don't know, you do, that's two numbers, right? The whole number or the remainder. 3 plus 1/4 times, in parentheses, must be, because you want to add first, times 8. which is 26 feet. Okay, so over here, I'm gonna do the next one, which is 2 3/8. So why don't you hit pause and try to do this on your own. Okay, so for the width here, there's my scaling ratio. And I know that this is 2 3/8 inches on the map. How much is it feet? So I cross multiply. 1/8 times x equals 1 times 2 3/8. That's 2 3/8. And this time I'm going to divide both sides by 1/8. Right? You can do either one. So if I divided it by 1/8, this is how I'd put it in my calculator. 2 plus 3/8 divided by 1 divided by 8. Notice the parentheses. Notice how I did that. And I don't think it's 26 feet, but let's figure out. Why don't you try to figure out, pause it, and you can figure out how many feet that is. And I got 19 feet. Okay, so the last step is to find the square footage. And from the last section, this one here is 26 feet. From the last section, how do you find the area of a rectangle? That's basically what we're doing. And it's going to be area equals length times width, which in this case, area equals 26 times 19. Put that in your calculator and you get 494. 494 what? This is what happens. It's not $494. I should have put the units in. Feet, feet. So it's 494 feet squared.